Hello everybody and welcome to the Unit 5 of the ROS in 5 Days course. In this final unit we are going to talk about debugging tools. I'm going to be following this notebook here and we are going to be checking different debugging tools that ROS provides. So basically, what will you learn with this unit? You will learn how you can use ROS what the fuck, how to add debugging ROS logs, filter ROS logs, record and replay sensor data, plot topic data, draw connections between different nodes of your system, and basic usage of Erebus debugging tool. Okay? So, one of the most difficult parts in robotics is to know how to turn your ideas and knowledge into real projects. So there is something that is very common in robotic projects, which are errors. You will always find errors because the real environment, the real world is not like what you do in theory, what you do in simulations, what you calculate. There are always errors that are introduced. So it is very important to be able and to know how to debug these errors in order to be able to solve them. So that's why in ROS it is very, very important to know how to debug your programs. Okay? It's very important in order to be able to solve errors. So let's begin. The first tool we are going to be checking is this ROS what the fuck, which has a very funny name, by the way. But yeah, this tool is real and it's quite useful if you know how to use it and when to use it. So first of all, let's begin with this first exercise, let's say. So let's type here ROS what the fuck. There we are. Let's make this a little bit bigger. And here you can see some output, which now you don't know exactly what it is. We have here some error, warnings, okay? So, okay, let's analyze a little bit all of these. So, what does ROS what the fuck do? Basically, it checks two ROS fields. One is the file system issues, where it checks environment variables, packages, launch files, among other things, okay? And it looks for strange things, some things that he finds strange or odd that could be errors, okay? He really doesn't know if this is really an error, but it is something that it's a little bit strange, so it could be an error. So ROS what the fuck tells you this, and then you have to see to decide if that's an error or that is a normal behavior of your system. Okay? But here we have used it in a general way, just typing ROS what the fuck. Yes? But it can be used also to check particular files, particular launch files, for instance. So let's try this command here, which is this ROS launch WAM Arm demo files start demo.launch. So let's execute this launch file. Okay, so here we can see that there appears an error which says cannot launch node of type WAM reproduce trajectory WAM Arm demo node. Can locate node. So basically it cannot locate this WAM Arm demo node in the package WAM reproduce trajectory. So this is the error that we get when trying to execute this launch file. So now let's try to analyze this launch file with ROS what the fuck. Let's see what happens. So let's go to this package, WAM Arm demo, and let's execute ROS what the fuck of the files, to the launch directory. Here it is. ROS what the fuck of the files start demo.launch. Let's see what happens now. Let's make this bigger. Okay, so here it appears this error, basically this one here. Okay, this one it's not important in this case. Okay, so you have to focus on this one, which says several nodes in your launch file could not be located. These are either typed incorrectly or need to be built. Yes, so here you can see this error that appears here when analyzing the launch file itself. Yes, you can see it. You can see it here. The output of the command. So basically, what this says is that it can't find this WAM AF. Let's find it here. So basically, what it's saying is that this node, the WAM AF demo node, he can't find it. Okay. So basically, this is what ROS what the fuck is telling you. So it is advertising you that this node he cannot find it. You are trying to launch a node that ROS cannot find. Okay. So yeah, here you have it. Node ERWAM of demo node in package. It cannot find this node. Okay. So this is analyzing a single launch file with ROS what the fuck. Okay. Then this was related everything to the file system issues, and then the other thing that ROS what the fuck does is to check online graph issues. So basically, here what it does is to check inconsistencies in the connection between nodes, between topics, between the topics of an action, etc. Okay, so it tells you if something it is not connected, and this is not necessarily an error. Okay, this because it may happen that some topics, some processes, some services die, some topics are not connected. This can happen in our ROS system. So this is not necessarily an error. Yeah, but ROS what the fuck tells you this, so you are aware of this fact, and it's up to you to decide if that's an error or if it is something that in your system it's regular. Okay, so yeah, let's type again this ROS what the fuck command, the general one. Here we have the output we saw previously. So basically here, these warnings here, yeah, these things we see here, are these graph issues. So basically it says that there are some subscribers that are not connected to the topics that they are meant to be connected to. Here we have it. The following node subscriptions are unconnected. Okay, so these subscribers are not connected to the topics that should be connected, and this is, in this case, this is not an error. Yeah, because this is there are certain nodes that only connect at the beginning or in certain moments. Okay, so in the case of this system, for instance, these are not errors, but ROS tells me this, so I know. Okay, but as I've said before, this is not necessarily an error. Okay, so I get the information and then I decide if this is normal in my system or if this is an error. Okay, and then the other one, here it is. It says that this node, the RDF spawner, has died. In this case, this is also normal because the spawners usually, when they have spawned the robot, for instance, they die. Yeah, so they do their work, which is to spawn an object, to spawn something into a simulation, and then they die. Okay, so this is normal. But anyways, ROS what the fuck warns me. Okay, says, hey, this node has died. Okay, so you know if this is normal in your system or this is an error. Okay, great. So let's move on. The next thing we're going to see are the ROS debugging messages and Arcuti Console. Okay, so up to this point you have been probably using prints in your codes, in the exercises you have been doing. You probably were using prints in order to debug some things, to print some messages. Okay, so this is not the proper way to work in ROS. The proper way to work is with ROS logs. Yeah? And ROS logs allow you to print also in the screen as a regular print, but also it allows you to store these logs in the ROS framework. So you can then classify them, sort them, filter them, whatever you want. You will see this a little bit later. Okay, so then in every logging system there are always levels of logging. In ROS, so we can see here, let's make this bigger for a moment. In ROS we have 5 levels, which are fatal, error, warning, info, and debug. Okay? And each level includes deeper levels. So this means that if, for instance, I set in my log system the error level, the messages for error and fatal will be shown. If I, for instance, choose the warning level, I will receive the messages from warning, error, and fatal. And if I choose the debug level, I will receive all the log messages. Okay? So each level includes deeper levels. The fatal is the deepest level, of course. So let's do a very quick exercise, which is to execute this code here. We can execute it, as you know, with clicking here in the play button or hitting Shift Enter in the keyboard, however you want. So yeah, let's execute this piece of Python code. There we are. Let's make this a little bit bigger. And now this starts to get full of log messages. Okay, let's stop this. Stop. There we are. Okay, so as you can see here, I have the debug level set it up. Okay, so I will receive all the messages. I am getting debug messages, info messages, warning messages, error messages, and fatal messages. So I have all of them. Yes? So this is a very, as you can see, this is a very, very simple Python code. It is just to test this logs system. So the best place to read all the logs issued by the ROS system is the topic ROS out. Okay? So if I come here and I do a ROS topic echo of the ROS out topic, here I will be able to check all the logs that are printed by my ROS system. Okay, in this ROS out topic. So let's do a very quick exercise, which is to create a package that has a launch that launches a Python file with the previous code. Change the log level in a node and see how different messages are printed. Okay, so let's create a package which I'm going to call I think that later I will use this, so let me I'm going to call it like this. Okay, there we are. So here it is. Now let's create a launch folder on the source folder. Now in the source folder, let's add this logger example.py, and I'm going to copy the following code. This code here. Let's paste it here. Excellent. And then Yeah, let's create a launch file for launching this. Logger launch, for instance. There we are. Package exercise 5p1. The name of the node is log demo. The type is logger example.py, and finally let's put the output to screen. Okay, there we are. Packages are 5p1, for example, log demo. Log demo. There we are. Okay, so I think it's ready. So let's launch this code here. Package. Yeah, here I can check all the logs because I have the output to the screen, and also if I have if I check the ROS out topic, here you will be able also to check these log messages, yes, which come from the file logger example.py, yes, and here these messages end, there is a missing droid, the Emperor Cappuccino is done, the rebels are coming time, the thermal exhaust 453 rebel, the main. Okay, here I have all, I can visualize here in the message field all the log messages that are being printed, and I have information of the name of the node which is publishing it, the file, whatever. Okay, excellent. So let's stop this. Great. But what happens? In this case, this is a very simple example, yeah, and even with this, there is a point where there are too much logs, and it is impossible to be able to see what is going on. Yes, imagine this is just one node. This is just one node which is publishing logs each 2 seconds, more or less. But in ROS systems, you can have many nodes, like tens of nodes, which are publishing logs every second. So this will reach a point where this is impossible to control, impossible to read, and impossible to manage. Yes, and this is where the Arcuti Console tool comes in handy. Okay, so let's check how this tool works. Let's launch again this code here. There we are. And now let's launch here in another console the Arcuti Console. There we are. Let's open a graphical tools window by clicking on that button. There we are. And something similar to this will appear. Yes? There we have it. Okay, let's make this a little bit bigger. Yeah, so what is this? Basically, the Arcuti console is divided into 3 subpanels, as you can see. 1, 2, and 3. Yeah. So the first panel outputs the logs. It has data about the message, severity level, the node generating that message, and other data. It's here where you will extract all your logs data. So the first panel, as you can see, here all the log messages are printed. Yeah, we have the message, severity, node, the timestamp, topics, and the location. So the program that is publishing this, okay? Here I have all the logs printed. Then in the second panel, the second panel allows you to filter the messages issued on the first panel, excluding them based on criteria such as node, severity level, or that it contains a certain word. To add a filter, just press the plus sign and select the desired one. So here I can add, for instance, containing, from node, from time range, from topic. I can add here filters in order to select which messages I will see and which messages I will not see. So for instance, I can here click to not see the messages, the fatal messages. If I select here, the fatal messages will be removed. If I select the error messages will be removed, and so on, okay? In this case, here it filters messages with the severities that you select. You can add here other type of filters, whatever you want, even some custom filters, okay? Then finally, the third panel allows you to highlight certain messages while showing the other ones, okay? So here you can highlight some messages, for instance, the end word. It still shows the other messages, but it highlights the ones which contain the word end, as you can see. Yes? I can highlight the revel word, for instance, and it highlights the logs which contain this revel word. Okay? So these are basically the three main panels that this Arcuti Console, and this is very useful when you work with a huge amount of logs. Okay, as you can see, this is very visual and very easy to understand and easy to use. Okay, excellent. So let's stop all of these. Great, so the first thing we are going to see is to plot topic data and Arcuti plot. This is in robotics, this is also a very, very useful tool because you need to check values, for instance, velocities, inclinations, strengths, torques, I don't know. And you need some kind of graphic tool that is able to show you all of this data in a visual way, in a way that you can analyze it easier. Yes, for instance, with a plot. Okay? And here is where Arcuti plot comes in handy. Yes? So let's have a look at this tool. So for that, let's follow this exercise, and the first thing we are going to do is to launch this node here. There we are. Start demo.launch. It will start to do movements, this WAM Arm. Excellent. So in another shell, let's execute this command here. ROS topic echo joint states. So we are going to have a look at the states of the joints. Excellent. So as you can see, knowing what is going on here in the position of the different joints of the robot with just these numbers, it's a little bit difficult, a little bit cumbersome. So let's use Arcuti plot in order to visualize this data. So let's launch Arcuti plot. There we are. And it will appear as always in the graphical interface window, which I have opened before. Here we have it. So let's maximize this. Excellent. So here I have my Arcuti plot tool. So let's follow this. In the topic input located in the top left corner of the window, you have to write the topic structure that leads to the data that you want to plot. Bear in mind that in order to be plotted, the topic has to publish a number, of course. Once written, you press the plus sign to start plotting the topic. Excellent. So in the case that we want to plot the robot joints, we need to plot the topic joint states, which has the following structure. Here we have it. This is the structure of the joint states topic. It has a header, a string with the name, and then different flows with the position, the velocity, and the effort values. Okay? Then, to plot the velocity of the first joint of the robot, we will have to type joint states slash velocity and the value 0, which corresponds to the first joint of the robot. Okay? And then you can add as many plots as you want by pressing the plus button. So for instance, let's try to do it like this. Let's put here the joint states velocity. As you can see, it automatically autocompletes, yeah? And here I will put the 0 value. As you can see, once, so now I cannot add anything. This button is not available, but once I put a 0 here, this plus button becomes available. So if I add this, now I am plotting the velocity value of the joint 0 of the robot. Yes, as you can see, it is changing like this. And if I want, I can add here the joint 2, for instance. Here I have it in red, so now I have the joint 0 and the joint 2. Excellent. So you can play a little bit with this, if you want, trying other topics, other joints, whatever you want. I leave it up to you. So I will now stop this. Great, so the next thing we are going to be checking is this node connections and Arcuti graph. So is your node connected to the right place? Why are you receiving data? Why are you not receiving data from a topic? These are questions that are quite usual in ROS. If you have been working along the whole course, probably you were expecting to receive data from a topic and you don't. You expect to publish into a topic and you don't. So what is going on here? When this happens, what is going on here? So this Arcuti graph tool can help you to figure out what is going on in a situation like this, because it displays a graph of the nodes that are running in ROS and their topic connections. Okay? Now, it's important to point out that it seems to have problems with connections that aren't topics. Okay? So this is also important to bear it in mind. So, let's have a look at this tool anyway. So let's execute this Arcuti graph. Let's do it here, for instance. So now we are going to launch the Arcuti graph of this system. And here we have a graph of the different nodes and topic connections in our system. So here we have the joint state, which is connecting the joint state relay and the joint and the robot state publisher nodes. Here we have another topic, which is the WAM joint states. So basically, here in this screen we have a couple of elements. One is the refresh button, which is this one here. Here we have it. And basically it refreshes the information in the case that you are adding nodes to your system or whatever. Okay, and then you have the filtering options, and yeah, these are basically these boxes we have here. So for instance, you can filter with just topics that are active, nodes only, you can filter here by names. I don't know, for instance, I can filter in order to just visualize this joint states array. In this case, this joint states relay node, whatever. So here you can filter also in different ways. Yes? So yeah, here you have, for instance, an example where you filter to just show the gazebo and the joint states relay. Yes? Let's make this bigger. As you can see, it's gazebo, comma, joint states relay. And this way you just visualize these two nodes and their connection. Okay, so this tool is also quite useful, and it's very easy to use. Here you have a very easy example. I will let you do it alone because it's very simple. It's just to create a package that launches a simple topic publisher and a simple topic subscriber, which you already at this point know very well how to do. And then you visualize this connection with the ROS graph tool. It will look something like this. So you will have the publisher node, the subscriber node, and the topic, which in this case it's named counter. Yes, so this is very simple. Then let's move on. We are going to have a look at how to record experimental data, which is done using ROSBags. So, for instance, this is very useful in cases that, let's say, you go to a university or whatever, and you get to work during just one day with a robot, which is very expensive and you cannot afford, but you get to work with them, to test it, to study it one day. Okay? Then what you can do is to record everything you do, record or for some specific task, you can record the experimental data, which is stored in the topics, and you can save it into a file. You can save all the information that is published into a topic. So what the robot sensors are detecting, how the robot is moving, using the command vel topic, for instance. You can record all this data that is published into a topics and save it into a file. And then later, when you don't have access to the robot anymore, you still have that data, so you can simulate in your simulation the behavior of that robot, the exact same behavior of that robot when you were working with the real robot. You can reproduce exactly that, the experiments you did, everything you recorded, you can reproduce it in your simulation. Okay, so this is a very powerful and very nice tool. This is done using ROSBags. So, the commands for playing with ROSBag are basically in order to record data from the topics you want, you use this command here, ROSBag record minus capital O, name of the bag file .bag, and then a list of the topics you want to record, topic 1, topic 2, topic 3, whatever. Okay, so it's this command here, ROSBag record minus O, the name of the bag file where all of these will be saved, and a list with the names of the topics you want to record. Okay, then to extract information about the recorded data, about the file, it is this command, ROSBag info and the name of the bag file. Very easy. And finally, to play this data, to play this recorded data, you just type ROSBag play and the name of the bag file. Okay? So, replaying the data will make the ROSBag file publish the same topics with the same data at the same time when the data was recorded. So everything will be exactly the same as when it was recorded. Okay? This is important to know. So, for instance, let's do this example here very quickly. So let's execute this launch file. There we are. Then let's execute these commands as well. ROS cd src. Now here I can execute this command which is ROSBack record -o, laser.back and laser scan. Okay, so this command, what we'll do will be to start recording the data, publish it into the laser scan topic, and it will save all this into a laser.back file. Okay, so let's execute this command. And as you can see, it starts recording, and whenever I press Ctrl C, it will stop recording. So I will stop it now. So as you can see here, a new file has appeared, this laser.back. Okay, so now I can retrieve information from this using this command, rosback info laser.back, and I get information about this recorded session. So for instance, the path, the name of the file, version 2.0, duration 5.1 seconds. This is always like this, yeah? So this is not an error. It is always like this, January 1, 1970, okay? This is always like this. Then the size of the file, the messages that it contains, compression, types, which type of message it is used into this file, which is obviously sensor messages laser scan, and the topics which have been recorded, which in this case is just one, which is laser scan. Okay, excellent. So now I won't do all this. I will let you finish this exercise, okay, because this is interesting. But here you will try to reproduce, to play this recorded data, okay? You will try to do this here, but it won't work. Well, it won't work. You will see why, okay? So yeah, here you will find out that there are a couple of things that are wrong, okay? But it's important that you see this, because this way you will learn it before. It is important that you know this, so that's why I want you to do it by yourself, because if you do it, you will struggle with it and you will learn it better. So basically, the first thing that you will notice is that when you echo the topic laser scan, you get sudden changes in values. Okay? And why will this happen? It will happen exactly because of this. Because you will be publishing your recorded data into the laser scan topic, the data you recorded into the back file, while the system is publishing also the data that is getting in the real time. Yes, so Gazebo is publishing its data as it always does, and you are also publishing into the same topic your recorded data. So that will be a mess. Yes, so that's why you will see strange values and some strange things. Okay, so basically, what you will need to do is to pause the physics of Gazebo so that Gazebo doesn't publish anything, and then reproduce your data, and then everything will be okay. Okay, and then later you will unpause the physics using also this command. But basically, it's something like that. Then later you will have another issue with the time, but okay, you will discover that. Okay, I want you to work with this, to struggle with this, because it is important that you learn it well. Okay, then let's move on. Okay, yeah, just you have this command as well, which is in order to record everything. Okay, if you type this ROSback record -a, it will record all the topics in the simulation. Okay, great. Then we are arriving to the end, which is Erebus. Okay, so basically Erebus is the holy moly. Okay, it is the most important and most amazing tool for debugging ROS systems. Okay, so Erebus is a tool that allows you to visualize images, lasers, point clouds, transformations, robot models, even robot models. The list is endless. Okay, you can define your own markers. We in fact have a course now of Erebus markers, very interesting. But basically, Erebus is a massive and very useful tool. Okay, in this unit you are going just to scratch the surface of Erebus, but you will see that it is a very powerful tool. Okay, but there is one thing that it is very important that you need to know very well, that Erebus is not a simulation. I repeat, Erebus is not a simulation. Erebus is a representation of what is being published into the topics by the simulation. Okay, but Erebus is not a simulation. Erebus is a way of visualizing all the data that is published into the topics. Okay? Okay, so yeah, let's run Erebus so that you can get a first contact with it. And you can launch it like this: ROS run Erebus. There we are. As always, it will appear here in our graphical tools. Here we have it. Okay, so this is the basic look of Erebus. Then, Erebus contains different sections. So, basically you will need to be concerned at this point about a few elements. First of all, you have the central panel, and here is where you will visualize the data itself. It's a 3D space that you can rotate, translate, and zoom in, zoom out. Yes? So you can zoom in, you can rotate it, you can also translate it, you can test this depending on if you are using a computer or other. This might be different, so you can test with your keyboard how to do all this. Now I'm translating, rotating, zooming in, zooming out, okay? But this here is the central panel, and this is where you will visualize most of the things, okay? There are some things like images and other stuff that you will visualize outside this, but basically this is the main window where you will visualize everything, okay? The central panel. Then you have the left displays panel, and here is where you manage, configure all the elements that you want to visualize in the central panel. So here I have the robot model, the laser scan, and here you can configure everything so that you can visualize it correctly and properly in the central panel. Okay, you can add elements, remove them, rename them, whatever you want. Okay? Then, in the global options, you have to select the fixed frame that suits you for the visualization of the data. Okay? This fixed frame is the reference frame from which all the data will be referred to. Okay? It is talking about this fixed frame here. In the global options, the fixed frame. Okay? Then, the add button will allow you to add new elements to visualize. Okay? So, for instance, here it adds the TF element, but before that I'm going to select here the proper link in order to visualize this properly, which is WAM link base. There we are. Let me take out this. Okay, so now I have set the correct frame for my visualization, which is this WAM link base, and now as you can see I can visualize perfectly my robot here. But remember, this is not a simulation, okay? This is just a representation of topics of the simulation. Very important, okay? Then I'm gonna add this TF element to visualize the transforms. There we are. So now, if I take out the robot model for a moment, here I can see all the links of my, all the links and transforms of my robot, yeah? Here WAM link 4, here I have the footprint, the base, link 5. Here I have all the links. Yes, I can select them here, show just, for instance, the laser, the camera, or enable it. Okay, I can here configure how I want to visualize this. Okay, then, yeah, now let's launch this command here in order to start the demo. Execute this command here and start visualizing everything. So I'm going to launch the demo to start moving this. There we are. And now, here in Erebus, you will see that everything starts to move. Yes, I can also add the robot model. There we have it. Amazing, right? This is an amazing and very, very powerful tool. Okay? So I think I will end up here, this explanation, because here you have another error that I will let you do it alone. So yeah, I will end up here my explanation, this video. So I hope you have liked this debugging tools video. And well, if you have reached this point, it means that you have finished this course, the ROS in 5 days course, so congratulations. And I really encourage you to try other courses, because we have many, many interesting courses in the Robotic Academy. Okay, so goodbye and good luck.